solve this slightly non-standard logarithmic equation. Let's go ahead and write down the definition or the exponential equivalency statement. So if we have log base b of x, that doesn't read b to the x, it's log base b and the input argument's x. Okay, let's say that it's equal to y. And recall that a logarithm is a mere exponent. Okay, so this statement right here would be similar to where 4 would be like your y here, b would be the root x, and then x itself would just be this entire expression right here. Now this is absolutely equivalent, and I'll connote that with a double arrow. B raised to the y is equal to x. Okay. Again, for every logarithmic statement, there's a corresponding exponential statement. They're said to be inverse functions. All right. Now, let's take advantage of that to solve this this problem. We literally take the logarithmic statement where the square root of x is the base. A logarithm is an exponent, so this 4 that you see here comes down to here. All right. Now, so you can think of 4 copies of the square root of x. Well, the square root of x times the square root of x is just x. So this is the same thing as x squared is equal to 78 minus 7x. Again, a lot of you might prefer to think of this as laws of exponents. The square root of x is 1/2. That's is the same as x to the 1/2. You multiply the exponents. But I think it's a little easier just to think of it as 4 copies of the square root of x, and you go the square root of x times the square root of x is x, square root of x times the square root of x is x, then you end up with x squared. Okay, it's a little less formal, but more into what's really going on. All right, now, so right here we have x squared plus 7x. Again, just writing down an equivalent equation equals to 0. Okay, and then we're looking for the factors of 78 that will result in, we know that the form has to be like this. It's got to be x plus something. And I'll just go ahead and write it. If it's going to factor, it has to admit this form, at least factor over the rational numbers. It has to at least look like this, with the order of the parenthetical expressions not really important. Okay. Now, of course, you just play the game of 2 times 39 is not going to give us a difference of 7, but 6 and 13 turn the trick right here. So this will be 13. And I don't know what I did right there. I don't know why I wrote that down. But let me erase that. Okay, let's replace that with what I intended. 6 right here. Okay. So you see the 13 minus 6 gives you the 7x as desired. And so what we see right here is we have 2 solutions, namely x equals to negative 13 and x equals 6. Now, if you go back and look at the original problem statement, this is the square root of x. So we have to assume, of course, that x is strictly greater than 0 because the log base 0 is not too exciting. So we're going to say that x has to be greater than 0. Log base 0 would be like saying 0 raised to some power, which nobody's going to get too excited about that. Okay, so we'll x has to be greater than 0, so we'll reject this. Okay, and then we'll accept this as our answer. Now, you may ask, well, how do you know it's the answer? Well, let's check. Let's put it in the original. Now, y'all, right up here, this would read log root 6, then 78 minus 7 times 6. 7 times 6 is 42. Equals to 4. And that certainly looks true, right? Because this is the same thing as log. Really, it's just a different set of symbols to say something that we've already talked about. All right, this is 78 minus 42 is 36, right? And certainly this is equal to 4 because the square root of 6 raised to the 4th power is certainly 36, right? And again, we just talked about that symbolically just a moment ago. Let me write this down. Yeah, the square root of 6 raised to the 4th power is equal to the 36. Okay, so that's it, folks. The solution is x equals 6. And I haven't seen many of these type of problems in college textbooks. Maybe that's been changed, but I've never seen one quite like this in a pre-calculus or a college algebra textbook. But maybe they're there and I just didn't notice. All right, thanks for viewing.